So there's various levels on these questions. So one of the questions that we ask for these is finding all possible. So that's a keyword there, possible. And another keyword here is rational zeros. So there could be irrational zeros potentially. There could even be non-real zeros. But we have this theorem that talks about if there are any rational zeros, I can make a list so that all of the rational zeros are in that list. There aren't any extra rational zeros that aren't in that list. So we make these fractions. We look at, for each fraction, we have a factor of the constant term on the top. And the denominator for each of my fractions is going to be a factor of the leading coefficient. I'm not sure why. Anyways. So one of the things that I like to point out is if I take a positive and divide it by positive, or if I take a negative and divide it by negative, in both cases, I get a positive answer. And if I take a positive and divide it by negative, or if I take a negative and divide it by positive, in those two cases, I get a negative. So if you play around and go a little bit more in depth with some of this, you can see that it might make sense to you to list out more options than what I'm listing out. But all four of those options are going to boil down to two options. So I'm going to kind of skim over that. So you do need to be careful and make sure that you're looking at the right numbers. Notice that that is an x cubed right there, and that's the largest exponent in this particular polynomial. So one of the questions is it a polynomial? So I look at the exponents. The exponents are 1, 2, 3, and 0. So this is the largest exponent, 3, and they are all 0 or counting numbers, so that it is actually a polynomial. So this is the leading coefficient, that -9. And let's color code this. So the zeros of, or the factors of 9 are going to be positive -1, positive -3, and positive -9. And then I also have to care about the constant term. And so the constant term is this -1, the term that doesn't have an x in it. And so the constant term only has one or two factors, depending on how you look at it. So positive -1. So when I look at all the factors of the constant, 1 is the only option for my numerator. If I just worry about the plus minus out front later. And then I have 3 possibilities for factors in the denominator. So the numerator can be 1, and the denominator has 3 options. So the denominator can be 1, 3, or 9 in this problem. And then we'll just stick the plus minus out front. So I could have positive -1, I could have positive -1/3, or I could have positive -1/9. Another question that I could ask is I could ask, find all the rational zeros. And there's a couple different ways that I could do this. Or I could just ask to find a rational zero. So I could just stop when I found one of them. And so remember that it's a 0 of the function if when I plug it into the function, I get 0 for an answer. For each of these numbers, you can plug them into that and see if you get 0 or not. You can use the undo feature on the ALEKS calculator to make this a little bit easier. So for example, maybe I would use the ALEKS calculator and I will type in all in one line, -8 times 1 plus 8 times 1 squared minus 9 times 1 cubed minus 1. Negative 8 and 8, that gives me 0. Negative 9, negative 1 does not give me 0. So I know that 1 doesn't work. And so, like I said, you could use the undo feature. So after you find out whatever that answer is and find out that it's not 0, then you could hit undo and you could go back and you could overwrite. So then you could stick that negative sign in there and we could check negative 1. So in this case, we got a positive 8 and a positive 8, so that's going to be 16. Positive 9, so that's not all going to add up to 0, so it's still not 0, so negative 1 wouldn't work. And you could just go through and check all 6 options and see if any of them work. So that would be one way to find all of the possible rational zeros. It would just be to go through your list and check them all and see if you get 0 or not.